Let's now see how we can equate the non-standard cell potential to the non-standard Gibbs free energy change for a redox process. So you remember we had delta G standard is equal to minus NF E standard for the cell. So we can take the standard cell potential, 1 molar concentrations, 1 atmosphere partial pressures, and equate that to the delta G standard for the process. But what if we want to know E cell for non-standard conditions? Well, we can look at correcting the Gibbs free energy change to non-standard states. And in the last chapter you saw this equation. So this is the correction term to correct delta G to non-standard conditions. So different from 1 molar or 1 atmosphere partial pressures. So we can take the standard delta G, correct it to non-standard conditions. So if we take delta G minus NFE, we can put minus NFE standard in for delta G standard, and we can put minus NFE for the cell non-standard for non-standard delta G, and then we'll have this equation. Remember, Q is the reaction quotient. It's like the equilibrium constant, the concentration of the products over the reactants. Now if I divide by -1 and by NF on both sides of the equation, I will get E non-standard for the cell is equal to E standard for the cell, so that's standard, minus RT over NF times the natural log of the reaction quotient. So I can take the standard cell potential, use this correction term here, so it contains N, the number of moles of electrons in the balanced redox reaction, the reaction quotient, and the temperature, and these two are constants. And then if I have the standard cell potential, I can correct that for non-standard states. This is called the Nernst equation.